Chapter 3 Numerical Descriptive Statistics. We are come from Group Assignment 3C. My name is CHUIN. My metric number is 277301. And my group members are Tancho Muhammad SHAHIDAN, Muhammad SYAHIR, and SYAZWAN. In this chapter, we will learn the topic about mean, median, mode for ungrouped data. The mean is sum of the observation divided by the number of observations. These are the formula of mean for ungrouped data and the formula of mean for population and sample data. Above is the population of data recorded the age of all students studied at UUM. What is the mean of the above data? The mean of the above data is 20.83. Above is the sample of data recorded the statistics test result of 8 multimedia students studied at UUM. Find the mean of the above data. The sample mean of the above data is 73.75. Median for ungrouped data is obtained by rearranging the data in increasing order. For odd number, the value in the middle is median. For even number, the two value in the middle is median. The position can be calculated by n plus 1 divided by 2. The above data have 6 values. The position of the above data is 3.5. Mode is the highest frequency of class or category. It can easily be obtained using frequency distribution table. The above data have 10 values. What is the mode of the above data? The mode of the above data is 60 because it is the highest frequency of class.
My name is Tancho. Metric number is 279792. I would like to talk about mean, median, mode for group data. Actually, the formula of mean, median, mode for group data is more complicated than the formula of mean, median, mode for ungrouped data. Now I would like to explain about mean for group data. The formula of mean for group data is cumulative f multiply m and divide by n, where f is frequency, m is midpoint, and n is number of values. We must see properly what the question gives, as the symbol of mean and n for population and sample is not same. For population, the symbol of mean is microsign and n is uppercase n. For sample, the symbol of mean is x bar and n is lowercase n. Now let me give you a question. The students are part of UUM students. Find the mean. Look at the question. We know that the students are a sample and UUM students is population. The question has helped us calculate the M and FM. So we can just write down the formula of mean and put the values inside the formula. After that, we can get the answer of mean for this question is 54.3 marks. Actually, if the question never gives us midpoint, we can find it with the formula upper limit plus lower limit and divide by 2. Next is median for group data. First step, find a class contain a median with using a formula cumulative frequency divided by 2. Second step is find the median using the left side formula. We must know that uppercase F is the total frequency before class median, LM is the lower boundary of the class median, and FM is the frequency of the class median. It seems difficult to solve, right? Let me give an example. Actually, this question is same with previous question, but this question provides class boundaries and cumulative frequency. First step, find the median class. and divide by 2 and the value is 12.5. With a value of 12.5 at the cumulative frequency column, we can know that it is third class, so we can know the value of F, FM, LM, and I. After we get the values, we just write down the formula and put the values inside the formula. So the answer of median for this question is 52.643. Next is mode for group data. Mode is a value that has the highest frequency in a data set. First, we need to find the class mode. Class mode is the class with the highest frequency. After we found out the class mode, we can put the values inside the formula. We must know that LMO is the lower boundary of class mode. Change 1 is the difference between the frequency of class mode and the frequency of the class before the class mode. Change 2 is the difference between the frequency of class mode and the frequency of the class after the class mode. Let me give you an example question. See the example question, we can know that the class mode is second class, as its frequency is the highest frequency. After found out the class mode, we can get the values of LMO, change 1, change 2, and I. After that, we just put all the values inside the formula, so the answer of mode for this question is 166.056. Next, I'm going to talk about the relationship between mean, median, and mode. First is frequency distribution with symmetrical frequency curve. If a frequency distribution graph has a symmetrical frequency curve, then mean, median, and mode will be equal, so we can see the graph is symmetry. Second, for right skew or positively skewed frequency distribution, in case of a positively skewed frequency distribution, the mean is always greater than median and the median is always greater than the mode, so we can see the graph is right skew. Third, for left skew or negatively skewed frequency distribution, in case of a negatively skewed frequency distribution, the mean is always lesser than median and the median is always lesser than the mode, so we can see the graph is left skew.
Hello everybody, my name is Muhammad Shahidan bin TAIB and my metric number is 269560. So today we will learn about range, variance, and standard deviation of ungrouped data. First is range, where the formula is range equal to max minus mean, where max is the highest value and mean is the lowest value of data. Here is some example of the number. The highest value is 12 and the lowest value is 1, so range equal to 12 minus 1 equal 11. Second is variance. There is two types of variance. First is population and second is sample. In sample, the value need to divide by n minus 1. Third is standard deviation. The standard deviation also has two types. First is population and second is sample. Both formula are quite same. This is an example to find variance and standard deviation. First, we need to create a table to find sum all of the data and sum all the data after power by 2. Next, we find the total list of the data. After collect all the data, we need to take the data into the formula to get the variance. After that, we need to square root the value to get the answer for standard deviation. Guys, that's all from me about range, variance, and standard deviation for ungrouped data. Good luck.
My name is Muhammad Shahir bin SOHAIMI. Today I would like to teach how to do the variance and standard deviation in a grouped data. First, introduction. In this leaflet, we extend the definition of variance and standard deviation data which has been grouped. For example, this is the find and estimate of the variance and standard deviation of the following data for the marks obtained in a test by 88 students. can see the calculation as follows. First, we need to find the frequency and then the fx frequency times by mid-interval value. After that, the x square and fx square. Next, we need to find the mean first. The mean is like the formula is the total of the fx divided by x, and the final calculation we need to do the variance first, which is the total of the fx square divided by n and minus by x square. Next, we go to the Chebyshev theorem. First is what we know about this theorem. This is the empirical rules does not apply to all datasets. It's only to those all the bell-shaped, and even then it states in a term of approximation. That's how Chebyshev's theorem. This is some notes that we need to things to remember. After that, this is some important that we need to pay attention of the word that at least at the beginning of each of the three parts of Chebyshev's theorem. And this is some example. Next, we move to the empirical rule. This is some example or definition for the empirical rules. And let's do some exercise. The age distribution for a sample of 5,000% is a bell shape with a mean of 40 years. This is how we do the calculation. Move to the second exercise. Approximately 68% of the IQ score in the population lie between 90 and 10. And then 95% of the IQ scores in the population lie between 18 and 120. And lastly is the 99.7% of the IQ score in the population lie between 17 and 130. Next, we go to the solution.
What is measure of position? Measure of position determine the position of a single value in relation to other values in a sample operation dataset. Quartile, percentage, and percentile rank are examples of measure of position. Quartiles. There are three summary measures that divide a rank dataset into 4 equal parts. The second quartile is median of dataset. First quartile denoted as Q1, the third quartile and the Q3. So this is formula for measure of position. For the position of Q1, it was n plus 1 divided by 4. For quartiles 2 multiply n plus 1 divided by 4, and 3 multiply n
plus 1 divided by 4. Second was interquartile range or IQR. It was the difference between the third and the first quartile for data set. Now I will show you the example question. Table shows list the total student that visit school library for 2019 at SMK Salor. I write January, February, March, April, May, June, July, August, September, October and November, a whole year. It shows how much student goes to school library in 2019. So here the solution. Find the value of 3 quartiles. First, I arrange the data set, the sample in increased arrangement. For the Q1 is at position n plus 1 divided by 4 equal to 3.25. As to 2 multiply n plus 1 divided by 4 we get 6.5, and quartile 3 same, 3 multiply n plus 1 divided by 4 we got 9.75. After we count the quartile position, we get the quartiles on a value over each quartiles. For quartiles 1, we got 200 plus 200 divided by 2. It was 200 for quartiles 1. Quartiles 2, 250 and plus 250 divided by 2, we got 250, and quartiles 3, we got 300. So 300 plus 300 divided by 2 and equals 300. From what we see, the calculation is going to be like this. For quartiles 1, 200 was at third place in my increased arrangement. So we already know that for quartiles 1 we got position 3.25. So for quartiles 1, the value is stay at third place. So I got 200. Then we need to plus the value after the third, and it was 4, and I get 200 plus 200. Same for quartile 2 and quartile 3. Quartile 2 stay at 6th place and quartile 3 stay at 9th place. Now we need to find the interquartile range or IQR. So as we know, for the formula, IQR equal quartile 3 minus quartile 1. So quartile 3 is 300, and minus with quartile 1 250. So we got the IQR equal 50. What is lower and upper limit? Lower limit equal, the formula is lower limit equal quartile 1 minus 1.5 multiply IQR. So same as upper limit, but it was Q3 plus 1.5 multiply IQR. So from the observation, we already know that potential outliers same as lower and upper limit. To find the potential outliers for the lower limit, quartiles 1 was 200 minus 1.5 multiply 50, so we get to 125. And for the upper limit, quartile 3 300 plus 1.5 multiply 50, and we got 375. So the potential outliers is 125 and 375. For the last part, but not least, is how to draw box plot. So from the step 1, determine the quartiles, potential outliers and their adjacent value. Second, draw a horizontal axis on which the numbers obtained 1 and 2 can be located. Mark the quartiles and adjacent values with vertical lines. Connect the quartiles to make a box and connect the box to the adjacent value with lines. And for the last, plot each potential outliers with an asterisk. And at the right image is how box plot looks like. This example question is construct and interpret a box plot. So at the table, total student visit SMK Salor School Library in 2019 by month. So from the data we get last question, quartile 1 200, quartile 2 250 and quartile 3 equal by 300. From the last page of box plot image, we can see line of min and max refer to the minimum total student in the table, and max is refer to the maximum total, and it was 400 in the table. And then we plot data for quarter 1, 2 and 3 of each their value. Quarter 1 200, quarter 2 a median 250, and quarter 3 is 300.